Hi everyone, today we continue automating our database systems. In the previous episodes, we built a test station for engineers and a database provider, which will keep improving. Our ultimate goal is to create MES, Manufacturing Execution Software, or CRM, Customer Relationship Management System. Whether it turns out to be one or the other depends on the intended use. In production lines, it's MES, while in offices or stores, it becomes CRM. In other words, whether it's a factory or a front desk, the same logic engine powers both worlds, manufacturing and management. In the last episode, we programmed an algorithm to create a database table and record data into it. In this episode, we'll work on optimization and prepare for the next steps, building a SubVI, adding an event structure and setting up radio buttons and placing all of that inside a tab control. Think of it as organizing your workspace. We're turning our messy diagram into a well-structured dashboard. Let's begin by opening our project. Here you can see we already have the file test station. That's our first video, and the database provider, that's the second one. And here's the hidden sub-diagram global variable. We'll need the file db provider 1. Let's copy it, rename it to db provider 2, drag it into the project and save everything. Save all this project. Then we open the new file from the project, and as you can see, this is the front panel, the face of our application, and the block diagram. And yes, it's huge and cluttered, so we'll optimize it by creating a SubVI. Basically, we're taking a spaghetti diagram and turning it into a modular pasta, cleaner, shorter, and easier to digest. We'll start by expanding our while loop and case structure. Let's stretch the while loop and move all the Boolean controls around a bit. Now we need to find the indicators and move them lower into the case structure, since they won't go inside the SubVI. The tables indicator won't be part of the SubVI, the operator indicator won't go either, and neither will the global variables. We'll move them outside the case structure instead. Basically, we'll clean in the house, pulling out everything that doesn't belong inside our SubVI to keep it lightweight and efficient. At the final stage, we need to swap the positions of the property node and dbTools close connection function. Delete the old connections, move database close connection up, and place table property node last. Then do a little cleanup with cleanup wire and reconnect property node value and columns properly. Think of this as decluttering your workflow. Same logic, better flow. Now we select everything inside the case structure except indicators and property node. We highlight all the way up to dbTools close connection, including it. Then from the edit menu, choose create SubVI. Great. Now everything is neatly packaged into our SubVI. Let's bring back the global variables into the case structure and hit clean up diagram. This automatically adjusts everything by size, which makes the diagram look cleaner. You could say we just turned a massive data jungle into a well-pruned garden. We can minimize the block diagram now, though we still have a little tidying up to do. Let's expand the while loop just a bit because we'll need space for new structures during optimization. Move, loop, stop, and timing elements down for better layout. Adjust their alignment, make sure everything looks organized. In LabVIEW terms, this is like moving furniture around before hosting an engineering meetup. Everything should be in its place. Now, we need to save the SubVI, but first open the SubVI itself and take a look. We're going to edit the icon. Click the icon, select everything, hit delete, and type the new label, db, table, create, and load. One word per line. Press OK, done. Our icon is ready. Basically, we just gave our SubVI a LinkedIn level title, short, descriptive, and ready to network. Next, save the file in the same folder as our project. Let's create a new folder named SubVIs. We'll need it for future components, and save this file as SubVI database dbtable create load.vi. Then drag the new folder into the project. LabVIEW might say the path already exists. That's fine. We confirm with OK. Now drag the SubVI file into the SubVI folder. Perfect. In other words, we are onboarding our new SubVI into the company project structure, HR approved. After that, go to File, save all this project, everything saved. Now we need to adjust terminals and connections. Open the SubVI block diagram and you'll see operator ID on one terminal, that's fine. Next we have data, array, and tables. We'll move the tables terminal closer to operator, disconnect the current terminal and reconnect it where it belongs. It's like reorganizing your team. Right people, right seats, better results. Now, connect the two wires below, column headers and value, where data goes to the right terminal and array to the left one. Done. That's our right brain, left brain wiring, keeping logic on one side, visuals on the other. Let's save everything again, close it, and clean up with Ctrl+B to remove any broken wires. You'll see now the array connects neatly to column headers and data to value. Since the table belongs to the property node, to this property node, let's move it a little closer for clarity. We are basically doing cable management, but for virtual wires. Now we need to add an event structure. Go to Structures, Event Structure, select it and move it into place. Let's check what event structure actually does. Open Context Help. It waits until an event occurs, then runs the appropriate case to handle that event. The event structure has one or more sub-diagrams or event cases, exactly one of which executes when the structure executes to handle an event. This structure can time out while waiting for notification of an event. Wire a value to the timeout terminal at the top left of the event structure to specify the number of milliseconds the event structure waits for an event. The default is -1, which indicates never to timeout. We wire a constant to the timeout terminal, top left. Let's set it to 100 milliseconds, same as our little timing clock before. That means we can remove the duplicate timer to keep things clean. Save it. Now, let's jump to the front panel. We'll expand the layout. I already have some buttons ready, so let's copy them over. These are our radio buttons. Careful while copying so we don't break the cluster. We'll have buttons like Home, Test Station, Database, Search, and Info, plus a Power button that replaces the Stop button. That way, everything looks consistent and in style. Next, from Energy Style, add Layout, Tab Control. Stretch it out a bit, maybe even more than a bit. Rename each tab to match the radio buttons. First Home, second Test Station, then DB, then Search and Info. Rename Tab Control to Tab Main. Align everything neatly on the left and hide the label, since we don't need it. Now, we'll place each section into its repetitive tab. DB provider on Home, operator ID on Test, the database table on DB, tables list on Search, and loop on the Info tab. Remove the old frame and Stop button, clean it up a bit. Now, let's find our new buttons, Tab and Power, on the block diagram. Right now, they sit outside the while loop, but we are about to fix that. We'll create a new event, choose Add Event, then select Radio buttons as the source, pick Value Change, and click OK. A new event appears. We'll keep the new value input and connect it to Tab Main. Change Tab Main to an indicator, add a case structure, and wire new value into it. Then choose Add Case for every value. Now every radio button has its own event. Home, Test, Database, Search, Info. Create a constant for Tab Main so it's easier to copy. Then in each case we paste the proper constant, Test Station, Database, Search, Info, and wire the arrow line through each of them. Double check everything, Home, Test, Database, Search, Info, all connected perfectly. File, save all. Now let's add another event case for the Power button. Again, choose Value Change and confirm. We bring Power source inside the event structure and connect the arrow wire as usual. Since we replaced the Boolean Stop button with Power, all we need is to create a constant and link it in this event case. Save again, check everything, timeout, true, false case is clean, Home and other values are good. Looks solid. You can think of this step as QA testing for your diagram, catching bugs before they turn into feature requests. Now we can close the block diagram and return to the front panel. The last thing left is adding some color and style. Open View, Tools Palette, pick up a color from the buttons and start coloring the interface. After that, hide the tabs, go to Visible Items, No Tabs, and save everything. Basically, we're giving our UI its brand identity, less engineering gray, more Silicon Valley polish. Now, our radio buttons work perfectly as switches. You can move from one tab to another, and the power button now acts as stop. Let's test the whole thing together with the test station to see how it behaves. When the database provider runs, the values sent by engineers appear right here. At the moment, the table is empty, but in upcoming episodes, we'll add auto-sizing, column optimizations, and other improvements. In short, this is our MVP moment. It works, it's clean, and it's ready for version 2.0. For now, we can see everything operating smoothly. The engineers measure, and send data. We receive it instantly. Current, voltage, and resistance are all here, even the timestamps. Everything looks great. That's all for today. In the next episode, we'll continue improving our program. Thank you for joining Laplanda Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to catch the upcoming episodes. Thanks for watching!